All right, so we just did use substitution. If you didn't do the previous assignment, you need to do the previous assignments, and you send me questions before you do this. If you've been just kind of holding off, waiting for a rainy day, it's rainy day has already happened, and you need to move up quickly because we're about to end this chapter, and you're going to be really surprised how fast that's going to happen because we are done after today with new material, and so we are going to have to honor that, and that's going to be fun. Send your complaints to the administration as soon as you want to. So I get integral from 0 to 1, and I'm on 7 now, so hopefully you know what you're doing. I got x squared plus 1 cubed dx. And so when these things have bounds, they do something different. It's actually easier, but you can do it exactly the same way. So your starting point's exactly the same way. You can go u equals x squared plus 1, because that's the ugly part. So du equals 2x dx. And you go, aha, 2x dx, I need a 2x dx. So I'm going to change out this problem. And I would go from 0 to 1. I would go set it up so I got my x squared plus 1, just like we were doing before, 2x dx. Okay. And then I've got everything lined up the way I want it to be, right? Just like we were doing the du problems earlier, okay? Except that since I needed a 2 here, I put a 1/2 out in front, just like before. Exactly the same. Doing problems just like we did before. Now, I'm going to replace everything with u, just like we did before, right? So I have my 1/2 out in front. I've got my integral sitting here. I got my u cubed. And then 2x dx is du, so I got my du. So just like before, everything's replaced with a u. But the bounds are different. Why are the bounds different? Well, because these are in terms of x, so I have to turn them into u's. How do I turn x's into u's? It's actually very simple. The answer is sitting right here. If I put a 0 in for x, I'm really putting in a 0 squared plus 1 for u. 0 squared plus 1 is, well, 1. When I put a 1 in there, 1 squared is 1, plus 1 is 2. So I'm now integrating from 1 to 2. Now you're like, well, that didn't feel easier. I'll show you why it's easier. Let's raise the power. Let's go ahead and do the integral, right? Integrate the 4th power divided by the power I get. Still got my 2 1/2 out in front. And now I'm going from 1 to 2. Now notice what's interesting is, now at this point in the previous one, you would have plugged your u back in. You put your x squared plus 1 back in. I don't have to. These are u's. These are u's. So just plug in the u's. So I get 1/8 2 to the 4th minus 1/8 1 to the 4th. And so 2, 4, 8, 16. So that gives me 2 minus 1/8, or 1 7/8. And so with bounds, I never go back to x. I switch everything to u, including the bounds, and I change the bounds by plugging in this values of x into my u equation. Now, it turns out that for most of these problems, if you were to put the stuff back in, okay, you're to put your u back in here and leave your original bounds 0 to 1, you'd get the same answer. And in fact, that would work. There's a couple strange places where it won't work. And the reason why is because what's continuous for this function might not be continuous for this function, so the integral might not work. You might accidentally trigger something that's not allowed. AB Central's never pulled that trick, so if you want to put the ugly back in, you may put the ugly back in. The one problem with putting the other problem with putting the ugly back in is, see these bounds? You have to change them. Otherwise, if you leave 0 to 1 in this equation, it's wrong because this is u. And so you have to switch these to u's anyways. So since you have to switch these anyways, so AB Central doesn't mark you wrong, you might as well go ahead and switch them and take advantage of the fact you don't have to put the ugly back in. Okay? Does that make sense? All right. So try 73. I will do 73 in just a moment. I'm going to let you pause if you want to. Go ahead and pause it if you want to. Try problem number 73. And I will do problem 73 with you in just a moment. I'll write it over here first. Doesn't seem to be. Sorry. Okay, so if you haven't paused yet, pause now. All right, here we go. U equals the ugly part. Ugly part's inside that square root bar, so it's x to the third plus 1. So du would equal 3x squared dx. I've got a 2x squared, so I can make that happen. So I'm going to pull the 2 out in front because that's not what I wanted. I wanted a 3. Integral from 1 to 2. I'm going to write this as x cubed plus 1 to the 1/2 power, because I hate square root bars. And then I'm over here, I'm going to have an x squared dx. Remembering, of course, I pulled the 2 out in front. So I need a 3, so I'm just going to put a 3 here. When I put a 3 here, I have to put a 1/3 out in front. So I end up with a 2/3 integral u to the 1/2 du. And then I have to switch these out. So I put a 1 in this equation. 1 cubed is 1, plus 1 is 2. So I put a 2 down here. Put a 2 in here. 2 to the third power is 8, plus 1 is 9, right? And so I've got this all set up. Raise its power by 1. Divide by the power I get. 2/3 are still up in front. And then I'm going to do that from 2 to 9. I recognize 3 times this is all 1, right? So I end up with 9 to the 3/2 power minus 2 to the 3/2 power. 9 to the 3/2 power, square root of 9 is 3, cubed is 27, minus, unfortunately this isn't going to go nicely, it's because square root of 2 is a square root of 2. So square root of 2 to the third power is 2 root 2, and there's my final answer. Yay! Okay, the rest of the problems are just like this. You just keep doing these problems until you fall down. It's fun and entertaining and good for you. So go ahead and do 7, 7, 7, 8. And yes, there is a quiz the next time we meet. Yes. Send your cards and letters to the administration. They love it when you tell them how much you love snow days.